Hello everyone, welcome back to my YouTube channel Better Call Paul. My name is Vivek Ford and we are in the YouTube playlist for machine learning algorithms. Here in this playlist, we have covered three videos, decision tree, random forest, gradient boosting, and in today's video, we are going to discuss about extreme gradient boosting, which is the next version of your gradient boosting. So why we prefer gradient boosting? Why not? Why we prefer extreme gradient boosting and why not gradient boosting? So there are some limitations of gradient boosting which are covered by extreme gradient boosting. Extreme gradient boosting uses some parameters, mathematical statistical parameters, which I am going to explain you further. So that's why extreme gradient boosting is used. It increases the accuracy bit. So what is XGBoost? XGBoost means extreme gradient boosting, an advanced and optimized version of gradient boosting. It uses decision trees, and of course, it learns mistakes step by step. Learn mistake from the previous model, improvise it, and give the output. It add speed and regularization and smart splitting. Extreme means gradient boosting is extreme gradient boosting means you can say it is a gradient boosting with brain, brakes, and turbo engine. And why XGBoost created? Because there are some problems associated with gradient boosting. It is slow, it overfits easily, there is no strong regularization. What is regularization? We are going to discuss further. It handles poorly on missing values. So XGBoost solves this by faster computation, better tree selection, penalizing the complex trees, and it has a built-in regularization. Built-in means in its formula, the regularization lambda is present. What is lambda? We will going to discuss. That's why it is XGBoost is more popular, and there is a detailed documentation and community support, help support is present for XGBoost. And what is the core idea behind it is like panel prediction means it is a output of various trees and base output. It learns residual errors, tries to reduce the loss and is penalized. Then if too complex, then it penalizes. Now I will show you step by step using my notepad and my pen. So let's see. I will just switch my screen. So we will start with this house price prediction data set, simple data set. There are four houses, their size in square feet, bedroom numbers, and their prices in lakhs. And here we will going to see some various concepts, some mathematical terms like one is gradient. Gradient means G. One is learning rate. One is uh, one is Hessian. And one is loss. So one is residual. So what is residual? Residual means actual minus predicted. Actual will be see at y, and predicted we will see as y cap. And and the loss function, the loss is equal to half of actual minus predicted whole square. Now, gradient means dabba L by dabba loss by dabba predicted price. Okay, so which is equals to predicted price minus actual price, which is equals to minus of residual. Residual. Just 1 second. Okay. So and Hessian will be a double derivative of loss function dabba y cap y cap was okay, which is equals to 1. If you do all this calculation, double derivative, if you calculate the double derivative, you will get 1 as the value. Okay. Now I will write down here like what is the residual. Residual I will denote as R. But first of all, XGBoost always starts with the average value. So what is the average of all these but the average of all the house prices is 45 because 25 35 means it is 60, then 65 125 plus 131 31 80 180 divided by 4, it is 45 will be the predicted price. So you can see here 45 45 45 is the predicted price of first model. Okay, so the residual will be equals to actual price minus predicted price. Actual price minus predicted price, which is equals to minus 20 uh, minus 10 plus 10 and plus 20. Okay. Now the gradient which is equals to opposite of residual as we see. So it is equals to plus 20 plus 10 minus 10 minus 20. I will explain you why we are using gradient, learning rate, Hessian, loss, residual. So first of all, we will write down this. Then the term Hessian. Hessian is equals to 1 as the double derivative is equals to 1. Okay. So now what is the importance of using learning rate? So learning rate, Hessian loss. So Hessian calculates how sensitive is your error, how fast your error is changing. So that is Hessian means H. Then gradient tells us where am I wrong, how much big is the error, what is the actual error, in which direction I am going. So these things are given by gradient. Residual means simple the difference between actual and predicted. This learning rate means this learning rate you can see here. Eta. Learning rate means how should I learn? How much should I learn? How should I improve? Normally, learning rate varies. Like I will show you for learning rate. The data size. If the data size is very small, then learning rate is 0.2 to 0.3. If it is medium, then learning rate is 0.1, or you can say 0.05 to 0.1. And if the data size is very large, then learning rate is 0.01 to 0.05. Okay. And what is meant by very small, very large? So if there are 300 trees, decision trees, if there are 1000 decision trees, then this uh, learning rate defines. Okay. So we take this from this value. By default, normally we take a Hessian value as 1. Now I will just put our data set. Means I will just uh, take a copy of this and I will paste it here. Okay. Now what happens? XGBoost split the data set and pick one with maximum gain. So we will split it as per the square feet sizes. If the house having a square feet less than 800, more than 800, I will just show you. If the size is size is 1 second less than 800, then the left node means this will have two nodes. One is left node and one is right node. Means our model will have left node and right node. Okay, so we are talking about this left node and this is right node. Okay, so left node will be they have gradients will be equals to plus 20 and plus 10. Okay, and sum of these gradients is equals to plus 30. Then sum of h is equals to 1 plus 1 is equals to 2. You can see here 1 and 1 because the square feet size of the house is less than 800. Okay, now on the right side, right node means here you can see it is less than 800 and it is greater than 800. Okay, so the right side gradients sum of gradients is equals to minus 10 minus 20 is minus 30 and sum of Hessian is equals to 2. Okay, now the formula for leaf weight means which leaf has more weight we will calculate. So weight of leaf is equals to minus summation of gradient upon summation of Hessian plus lambda. Okay, so here the weight will be is equals to minus, here the weight will be is equals to minus of 30 divided by 2 plus 1. We by default take the value of lambda as 1. Lambda is for regularization. So by default we take the value as 1 and here you will get value as minus 10. Similarly here minus of minus 30 divided by 2 plus 1 which is equals to plus 10. Okay, so from here what we learn, if the size of square feet is less than 800, then weight is equal to minus 10. If it is greater than 800, then weight is equals to plus 10. Okay, and here we will consider the learning rate as zero point 0.3. We will update the predictions with the learning rate. So how to do this? Now the new predictions is equals to old plus learning rate into tree prediction. Okay, which is equals to for example, what is our, I will just copy paste it. Okay, control C, control V. Okay, here you can see old is our like 45, no? So it is 45. For example, we are taking 45 plus theta is zero point 0.3 into tree prediction. What is the tree? What is the tree prediction? Is plus 10 minus 10. What we see, if this is no this is a tree prediction, you can see first tree prediction. Okay, minus 10 plus 10. So here it will be for example for this it is minus 10. Okay, I will show that first tree prediction. It is minus 10 minus 10 plus 10 plus 10. So new prediction will be is equals to 42, 42 and 48, 48. because 45 into means you can see here if you write down minus 10 this value, then 45 minus 3 will be equals to 42. So this is how 42 comes. Likewise 48 comes. So this is new prediction. Now let's build a secondary on these new predictions. So what is the residual of this? Means this is the residual 1, this is our residual 2. So 25 minus 42, what it is? 5, 12 and 5, 17. So it will be minus 17. This is minus 17. 35 minus 42, it is minus 7. Then 55 minus 48, it is plus 7. Then again plus 17, I think 48, yes, plus 17. So this is how XGBoost repeats. Now, previously we have this much errors. Now we have these errors. Again, we will multiply it with learning rate and multiply by tree prediction and old prices, old residual errors. So step by step, in extreme gradient boosting, we are optimizing the outputs. Here the regularization, we use a regularization lambda as 1 by default. So lambda value varies. I will show you lambda value and its effect. So lambda value, if it is 0, then there is a high chance of overfitting. If the value is 1, then it is balanced. If the value lies in between 5 to 10, then it is strong regularization. And if it is very large, then it is underfitting. Okay. And why regularization used? We see the formula of we see the formula and we see lambda in it. You can see, yes, here weight of the leaf means if the value of lambda is more, then denominator is more, then the weight is smaller. So it used for regularizing the leaf. Now we will see how our model, XGBoost model, Extreme Gradient Boosting model, works on test data. So for example, here we have a data of 900 square feet area house. For example, we have a house of square feet area, which is size of 900 and bedrooms are 2. Then what will be the price? So first of all, we see our model, our decision tree. One will predict the house of the price will be 45 because whatever data previously we have, we take the sum and we do the average, and the average is 45. That's why the first tree will tell that 45 lakhs will be the price of that house. After that, it will check whether the square feet area is more than 800 or not. You can see here means yes, here if the square feet area is more than 800, then plus 10 will be the addition of that leaf, otherwise minus 10, and alongside the learning rate will be 0.3. So here old means 45 plus 0.3 into now the area is greater than 800, so plus 10. Here will be plus 10. So 45 plus 3 will be 48. So here I will write down 45 plus 0.3 multiplied by plus 10. Why plus 10? Because the area is more than 800, which is equal to 48. Now, the second decision tree, they will have another feature, and then again they will add plus 5 minus 5. If the square feet area is more than 800, then add plus or reduce or subtract plus. So it will be same like 48 plus 0.3 is our learning rate multiply by plus 5 or minus 5. This 10 value, 5 value, and so on, this keep on decreasing. How this 10 value, 5 value comes? Because we see here the weight of that leaf will be calculated based on this formula. Weight of leaf is summation of gradient divided by summation of Hessian plus regularization term and whole negative. So from this we get this value as minus 10 or plus 10. Okay. Likewise, next time we will get plus 5 value or plus 2 value and so on. So this is how we get this plus 10 value. So here it will be equal to 48 plus 1.5, which is equal to 49.5. Found decision tree means tree P will give us value as 49.5 plus 0.3 multiplied by plus 2, which is equals to 49.5 plus 0.6, which is equals to 150.1. Okay, so this is how lag. Okay, so this is how our model will predict the price of the house which is having square feet area of 900. Okay. So we have discussed various mathematical terms, statistical terms used in extreme gradient boosting. Like we use gradient. Gradient tells us where am I wrong. Hessian tells us how sensitive is the data. Learning rate tells us how fast should I learn. And lambda regularization tells us how complex am I allowed to be. So this is how the upgraded versions of boosting techniques we use to increase the accuracy of our uh, machine learning algorithm of our model. In the next video, we will going to see what is light GBM and how to use it, what is the accuracy of light GBM and the differences of light GBM over XGBoost, random forest, and so on. So keep learning. If you like this video and this explanation, then please do like, share, and subscribe my YouTube channel. Here continuously I upload the study material and it will benefit you. It is not like you will get 100% clarity in this video, but this definitely adds some value. Means, of course, if I am going to learn something new, then I have to refer 5 to 6 references. Means it may be videos or study material notes or any blog post or anything like that. Then I will get you can say 85, 95, 90% of knowledge, 95, 90% of clarity of this video. So this is how we learn and we progress and we share our knowledge. Whatever we learn in public. We share our what we get from the internet. And if you like it, definitely support me. Thank you very much. We will see in the next video. Till then, bye bye.